Today we're going to talk about decimals. Students, you'll take notes just like you would if I were there. Now, when we talk about decimals and reading decimals, this decimal that I have written down, you need to read it in proper math terms. Proper math terms would not be 123.1234. To read that in proper math terms, it would be 123 and this part right here, just read it exactly the way you see it, 1,234 10,000ths. Include the place value at the end. So for another example, if I said 34.213, proper math terms would be 34 and 213 thousandths because it's in the third place value. So just want to make sure we're familiar with place values. Now, what if I had to round decimals? If you had 34 and 213 thousandths and I wanted you to round it to the nearest tenth, that would be to this place value. Now, how do we round? This is the one I'm concerned about. The one behind it tells me what to do. If that number behind it is 0 to 4, then I'm just going to get rid of it and it just stays at the 2. Now, if it's 5 to 9, it's going to cause this 2 to go up to 3. So right now, this would be 34 and 2/10. Another one would be if I had 14 and 969 thousandths. This 9 is the one I'm concerned with. This 6 tells me what to do. Well, it's in this 5 to 9 range, so that means that will cause this to go up to 10. Now, when that causes this to go up to 10, it raises the whole. So instead of being 14 and 10 hundredths, it would just be 15. We'll do one more. Let's say I had 31.27, which is 31 and 27 hundredths. This 2 is the one in my 10th place. This is the one it tells me what to do. Well, it falls between the 5 to 9 range, so I need to round that up to 3. So it'd be 31 and 3/10. The same thing works if I'm in the hundredths. So if I had 27 and 423 thousandths and I wanted to round it to the nearest hundredths, that is the second place. The third number tells me what to do. Remember, it's the same thing. If that number is 0 to 4, we just get rid of it. So it'd be 27.42, 27 and 42 hundredths. It just stays the same. Now, let's say this was 29 and 67 hundredths, or let's say 29 and 673 thousandths. Once again, that 7 is the one we're concerned with. Since the 3 tells us what to do, it just drops off at 29 and 67 hundredths. One last one. If I said 32 and 417 thousandths, there's my hundredths. This 7 tells me what to do. What will we do here in this problem? We will take that up. So it'd be 32 and 42 hundredths. So I just want to do a brief review with you on rounding decimals. Now we are going to talk about adding and subtracting decimals. So if I am adding and subtracting decimals, there's 3 things we need to make sure we do before we start to add or subtract the decimals. The first one is you must line up your decimals. And you can see I'm going to shorthand here a little bit. So make sure we write down line up decimals. So if those are my 2 numbers, which is 3 and 62 hundredths plus 18 and 57 hundredths, I'm going to line up my decimals. So that would be the 3.62, and I'm okay if you say that in the adding and subtracting if we're not looking for the proper math term. Then 18, make sure I line up my decimal, 0.57. Now, the second thing, what are we going to do? Fill in with zeros. Well, this one right here is missing a 0, so we're going to go ahead and fill that in. Next, we're going to bring down the decimal so that we don't forget to do that. And then lastly, we're going to add or subtract like normal. So if we add this, it would be 7 plus 2 is 9. 6 plus 5 is 11. Make sure you just put down the 1, carry the other 1. 8 plus 3 is 11, plus 1 is 12. Carry, 1 plus 1 is 2, plus 0 is still just 2. So my final answer runs in with my L, don't get that in there. It's going to be 22 and 1900ths. So let's do another one. Let's say I had 9 plus 3.245. Now, to line up decimals here, I have a problem where I don't even have a decimal. So if you don't have a decimal, the decimal is always located behind the number. Think of decimals as money. And we'd all want this 9 to be $9 and not 9 cents or 90 cents. So write it as $9. So that would be $9, and you can put the zeros if you want. Now line up the rest. The decimals there, it would be 3, 2, 4, 5. Our second rule was to fill in with zeros. Remember to bring down the decimal. Now add. 5 and 0 is 5. 4 and 0 is 4. 2 and 0 is 2. 9 plus 3 is 12. So our final answer for 9 plus 3 and 245 thousandths is 12 and 245 thousandths. Now, this works the same way if we are to subtract. So if you had 12.49 minus 7.25, the same thing. Line up your decimals, very first thing. So 12.49, and I'm just going to write it under this problem. Line up my decimal would be 7.25. Remember to fill in with zeros. Bring down your decimal. Now subtract. 9 take away 5 is 4. 4 take away 2 is 2. Now, can I take 7 from 2? No, that means I'm going to have to borrow, and I will borrow from the 1. That makes that 0. Now that is 12. 12 take away 7 is 5. So my final answer is 5 and 2400ths. Now, going to this problem, what if I wanted you to estimate? We're going to throw a little bit of that in there. So let's say I had the 12.49 minus the 7.25, and I wanted you to estimate that this time. Well, now round that, and always round it to we're going to round these to the nearest dollar. So think of it. If you had $12.49, is that closer to $12 or is it closer to 13? It won't be closer to the next dollar until you hit over the 50-cent mark. So this would be closer to $12. $7.25 would be closer to 7. So 12 minus 7 is 5. And remember, when we subtracted on this, we got $5.24. And what does $5.24 round to? $5. So let's do one more of those. Let's say I had 14 minus 7.32. Remember, once again, if I do not have a decimal, I'm thinking of this as money, so that means that's $14 to me. So the decimal is located behind. And it's okay if you put the zeros. Minus 7, line up your decimals. Fill in with the zeros. Bring down the decimal, now subtract. Now, I have a problem here. I can't take 2 from 0. I can't take it from that 0. I have to come all the way over here to the 4. So technically, I am borrowing 1 from 40. So if I borrow the 1 from 40, that is now 39. 10 take away 2 is 8. 9 take away 3 is 6. I can't take 7 from 3, so I'm going to have to borrow here. So it's 13 minus 7 is 6. So my final answer is 6 6/68. Now, what if I would have rounded this? Well, $14 rounds to 14, and where does $7.32? It rounds to 7. So 14 minus 7 is 7. $6.68, it rounds up to 7. So that is the way you are going to estimate. The last one before we moved into multiplication, what if I had integers? Yes, we all know what integers are. Those are our set of whole positive numbers, their opposite, which are negatives, and 0. So negative 5.62 plus a negative 12.9. Just because you have negatives and positives, you're still going to use your integer rules. What does your integer rule say that you do when you have two negatives? You add them. So I'm going to line up my decimal. So that's 12.9. Fill in with zeros. I'm going to bring a 0 up here. And remember, this is two negatives. Bring down my decimal. Now, what do we do with two negatives? We add them, and my answer is going to be negative. So just add 2 plus 0 is 2. 6 plus 9 is 5. Carry the 1. 5 plus 2 is 7. Plus 1 is 8. 1 plus 0 is 1. So my final answer is a negative 18 52/100. Now, this time we're going to move into multiplication. Now, when we are multiplying, so multiplication. Now, when you are going to multiply decimals, let's say I would take 3.7 times, and you might see it written like that, 2.9. Now, unlike addition and subtraction where we line up the decimals and fill them with zeros, we don't do that. We line up the digits. So you're going to line up digits, not decimals. So I'm just going to line up 37, and I'm not even going to bring the decimal with it, times 29. Now, once I line up the digits, I'm just going to multiply like I normally would. So 9 times 7 is 63. Carry the 6. That's 27. 27 plus 6 is what? 33. Now, when I move to my tenths, I'm going to put a 0 there. Might run out of room here. 2 times 7 is 14. Carry the 1. 3 times 2 is 6. Plus 1 is 7. Now, what do you do in multiplication? You add. 3 plus 0 is 3. 3 plus 4 is 7. And 7 plus 3 is 10. Now, what do I do with my decimals? Well, once again, we multiplied like normal when we have integers. Now, to place the decimal, in the product, and remember, product is the answer to your multiplication problem, you're going to count the number, I'm going to abbreviate there, of decimal places in each factor. So if I look back to my original problem, I had a decimal here and one here. So that means I'm going to move this 2 places. Now remember, if I don't see a decimal, where is it at? It's at the back. So if I move it over twice, my final answer is 10 73/100. So once again, you line up the digits, multiply like normal, and then you have to add. And then when you figure out where your decimal is, to place the decimal in the product, which is the answer, you're going to count the number of decimal places in each factor. There were 2 of them. So let's do another one. Let's say I had 1.2 times 1.6. Once again, line up your digits, So that would be 12 and 16. I'm not even going to put the decimal in there. I'm going to multiply. 6 times 2 is 12, carry. 6 times 1 is 6, plus 1 is 7. Get rid of my ones. Now 1 times 2 is 2, 1 times 1 is 1. Now I'm going to go ahead and add. That's 2, that's 9, and 1. Now to place the decimal in my product, I'm going to count. I had 1 here and 1 there. So I'm going to move it over 2 places, so my answer is 1.92. Now, what if I had to estimate multiplication? It works the same way as it did for addition and subtraction. 1.2 would be like $1.20. Remember, money is 2 decimal places, so technically that would be $1.20, which rounds to $1. Then you have $1.60, which would be like $2 because it went past the 50-cent mark. So 1 times 2 would be 2. Well, if I rounded $1.92, it would be close to $2. So on multiplication, you're just going to line up the digits, multiply like normal. Now, if you had integers in this, you're going to do the exact same thing. Remember, in multiplication and division, an odd number of negatives produces a negative answer. Remember, the odd man out is negative. 2 negatives, or an even number, produces a positive answer. Now, the last one that we are going to do on that part is the dividing. Now, this is where students normally struggle. Let's say you had 4.32, which is 4 32/100, divided by 3 6/10. Now, the first number is called my dividend, remember that, and my second one is the divisor. Now, in order to divide this, I'm going to have to use the house. Now, which number goes into the house? That's always a confusing thing. Is it the biggest number? Is it the smallest number? Is it the first number? Is it the second number? Does it matter? It does matter. And what I always tell my students over the years, this could be actually written like this as well. So hopefully you'll always remember this. Let's say, for example, in this problem we got the top number and the bottom number. But let's say, use the analogy that you're outside. You're playing with your brother or sister and you're wrestling around, and all of a sudden you pin your sibling down to the ground, and all of a sudden it starts pouring down rain. Who is going to make it in the house first? The first one's going to make it into the house, of course, was the one who was on top. So the one on top always goes in the house. So we're going to write it like this. Now, when you are dividing, you have to make your divisor a whole number, which is the number outside the house. Remember, the one who was pinned to the bottom. So in order to make that a whole number, I'm going to move it over 1 time. So now my whole number is 36. Well, if I move it over once in my divisor, I've got to do the same thing in the dividend. Then I'm going to take it to the top. So remember, you have to make the divisor a whole number. Then you move it over in the dividend and then take it to the top. Now divide like normal. And in division, remember, I always say, does math sound bad? And that stands for divide, multiply, subtract, and bring down if necessary. Now, first step is divide. How many times will 36 go into 4? It will not. You could put the 0 if you want. It's not necessary. We'll go ahead and stick it though. Now, how many times will 36, of course, then I'll have to go here to 43. Well, 36 will go into 43 1 time. So if I multiply, 1 times 36 is 36. Next is subtract. So remember, you're going to have to borrow, regroup here. 13 minus 7 is, or 6 is 7. Last is bring down. So I'm going to bring down the 2. Now I've got to start this process all over again. Does math sound bad? 36 divided into 72 is twice, and I'm going to put it over the 2. So now it's behind the decimals, you can see, because that's where I'm placing it. That's the value that I'm using. Multiply. 36 times 2 is 72. Subtract, it's 0, so I have nothing to bring down. So my answer would be 1.2, or 1 2/10. This would work the same way if these were integers. If this was a negative 4 32/100, that just means that my answer would be negative. All right, let's do one more. Let's say I had 12 95/100 divided by a negative 1 25/100. There's a negative. That's not going to throw me off. I just know that my final answer is going to be negative. Now I'm going to do my house. Which number always makes it into the house? The one on top. The 1.25 is out. I'm not worried about the negative. I'm just going to carry it up here because I know my final answer is going to be negative. If I make this a whole, that's now 125. I've moved it twice, so I have to move it twice here. Now, just take it to the top. Now, I'm going to divide 125 into 1,295. 125 will not go into 1. It will not go into 12. It will go into 129. How many times? One time. So I'm going to place it above the 9 because that's where I'm starting. So now, does math sound bad? I just divide it. Now I'm going to multiply. I know 1 times 25 is 125. Subtract. 9 take away 5 is 4. Those are going to be 0. Bring down. Now, does 125 go into 45? It goes in there 0 times. So I still have to say 0 instead of just bringing down first. So now you multiply that out. 0 times 125 is 0. Still have to subtract. I got 45. Now it's bring down again. I'm not done because I have a remainder here. We're not having a remainder. We have to divide out until we terminate. So I'm going to bring down a 0, annex a 0. 125 goes into 450. If I'm unsure, I can think of this as money. That's $1.25. Well, 2 of them would be $2.50. Another one would be $3.75. If I do more than that, I'm going to go over. So think of it, if you have to, as money. Anything you have to do as far as estimating or guessing to get to that point. So I know it's going to be 3. So if I multiply that out, once again, I just said, but I'm going to go ahead and do that. So 3 times 5 is 15, carry it. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. Remember, subtract. So now if I borrow here, 10 take away 5 is 5. 4, I'm going to borrow again. 14 take away 7 is 7, and then that was 3, so that's going to be 0. I'm not done. I still have 75, so I'm going to do another 0. Well, now, once again, here's a big number, and I'm thinking to myself, what could this be? Well, I know 3 times was $3.75. So if I think about that, if I double that, I'm going to get $7.50. So I know it's going to be 6. So I know that's going to come out to $7.50, and that's going to give me my 0. So my final answer is a negative $10.36. And so if I thought of this was money, it'd be a negative $10.36. Now, on division, when we're estimating, it's a little bit different. Multiplication, addition, and subtraction are the same. Division is a little bit different. We're going to use what's called compatible numbers. Once again, I'm going to abbreviate. Compatible numbers. when you are dividing, if you had something like that, we'll use that $12.95. And let's say I'm going to divide by, let's say, $4.35. So once again, I like to think of decimals as money because we all like money. So it helps you to understand them a little bit better. Now, in compatible numbers, the first thing you're going to do is to round the divisor. So round the divisor, remember? The divisor is the second number. It's the one outside the house, the one who is pinned to the ground. So $4.35, what does that round to? Well, that would be closer to $4. Now, I'm looking for a number that's close to $12.95. That 4 will go into perfectly with no excess, no remainder, nothing left over. I want it to be a perfect compatible fit. So the closest would be 12. Even though that's greater, if I rounded up, it would be 13. I'm not doing that because I'm looking for a number that's compatible with 4. 12 divided by 4 is 3. So in compatible numbers, you're going to round the divisor first and then find a number that's compatible that actually the divisor will go into perfectly. So if you had 36.92, divide it by, let's say, $7.12. Once again, we're going to round the divisor. $7.12 would round to 7. Now, what number does 7 go into that is close to 36.92 with no excess, no remainder, nothing left over? Well, that would be 35. 35 divided by 7 is 5. So that is compatible.